All right, today we're going to be solving exponential and logarithmic equations. What are those? Those are equations that have exponential functions or logarithmic functions in them. A couple properties to remember: a one-to-one property. Remember, if b to the x is equal to y to the x, or if log b of x is equal to log b of y, then x and y have to be equal. That's only true if they're equal. And our inverse property is another one that we use. If we take b to the log base b, then when we evaluate that is x. And if we take log b of b to the x, that is also x. So I'm going to start with exponential. I'm going to look at two types, simple and complicated. I'm going to work an example of each next to it. So with a simple exponential, you rewrite both sides of the equation in terms of the same base. And that's if this is possible. If it's not possible, then it becomes a complex one. So if I'm looking at this, I have 2, that's my base, x minus 3. Can I write 32 as a power 2? And I can, to the 5th. So if you can do that, it's a simple problem. Now we use the one-to-one property, using that one-to-one property, which goes right up to here. We know that we can equate these exponents. That's what that property says. So we will equate, use the one-to-one property to equate the exponents. And then we can solve that easily. So we can easily solve that. Plus 3, plus 3. X is equal to 5. So, and then you can always check it in there to see if it works. Oh, this was a 5. Oops. Erase that. Copy that down wrong. And you know why I knew I made a mistake? Because I checked it in my head and I realized I was wrong. We add 3, so x is equal to 8. So if I plug that in, 8 minus 3 is 5, and 2 to the 5th is 32. Now, if it's more complex, like this next one down here, you can't, if I'm looking at this one, I can't get 7 to some e power. So I need to isolate the exponential expression. So the thing with the exponent, I want to get by itself, so I'm going to move everything else away from it. So plus 2 on both sides, 3e to 2x is equal to 9, divide by 3, so we'll do the exponent all by itself. So e to the 2x is equal to 3. Then we'll take the log of both sides. I like to use the natural log, so just less writing. You can use any log. So I'm doing the natural log of both sides. So I know if I go up and look at my rules, this rule right here, if I have, this is a log of e to the e to 2x, then it's just going to be 2x. So that's going to be 2x is equal to natural log of 3. And then I can simplify that using inverse property, which was what I just did. Use that inverse property. And then I can solve this divided by 2. So x is equal to the natural log of 3 divided by 2. You guys should put that in your calculator. A lot of times when you're told not to use a calculator, that's where you would leave your answer. If you can't use a calculator, you put it in there, and you would get approximately 0.549. All right, so let's look at some examples before we go to the logs. So number 1, this is going to be a simple one because I can write 27 as a power of 3. It's 3 to the 3rd power. And then I can equate my exponents and solve. Now I can always check it, put it in there. 4 minus 3 is 3, and 3 to the 3rd is 27. Now, when I look at number 2, that is going to be a complex one because I can't make 3 into 2 to some power. So I am going to have to take the natural log of both sides, use my law of inverses. So that's x minus 1 is equal to the natural log of 3. Then I'm going to have to add 1. Oh, let me erase that. I left out by 2 there. Natural log. So this is going to be x minus 1 natural log of 2, that wasn't an e. I guess I could have taken the log of 2, that might have worked a little bit better. And that equals natural log of 3. And then I need to get this natural log on the other side, so divide by natural log of 2. I have x minus 1 is equal to the natural log of 3, divided by the natural log of 2, and then you can add 1. And there we go, there's my answer. X is equal to natural log of 3, divided by natural log of 2 plus 1. Or if I put that in my calculator, it's approximately 2.5. Now notice earlier when I said it would have been better to do the log 2, it was going to give you the same answer. Like if I had done log 2, x minus 1 is equal to log 2 of 3. Then I could have brought that down to x minus 1 log 2 of 2. Log 2 of 2 would just be 1, so that would go away. Equal to log 2 of 3. And then I would have to add 1. And then you can check that, and you'll get the exact same thing in the calculator that I got. I just prefer to use natural logs. To find the log, you do alpha window, and the log is number 5. So you can do a log base.
Christy Sunstrom, if you're in the building, please dial 85651. Christy Sunstrom, please dial 85651.
Same thing as if you use the natural log. I prefer to use the natural log. That's just my choice. All right, let's look at number 3. Number 3, something I noticed here at 3 raised to the log 3 of x. So that is the inverse property. That means that's just x. That right there, that's just x. You don't have to do anything on that problem. Just have to remember the property. Number 4, this is 5x is equal to 5 to the 1/2. Same base. So I rewrote it so they have the same base, so I know that x is equal to 1/2. Also, not much work on that problem. Number 5, can I write 125 as base 5? Yes, 5 to the 3rd. Then I can just set these equal to each other, my exponents. That is my 1-to-1 property. Then I can solve this. And x is equal to 3. Now, number 6. I could do natural log here. I am actually going to do something a little different. We'll make them the same base. And make this 2 to the 3rd. But remember, I have this x plus 2 equals, this is 2 squared, but I have that x minus 3. So because I made them the same base, which I can do, I can now equate their exponents and then solve. 3x plus 6 is equal to x minus 6, 1 minus 6, minus 2x. X is equal to 50. Number 7, I can make those the same bases. 6, x minus 3 over 4 is equal to 6 to the 1/2. So then I can equate my exponents and solve some basic equation solving right there. So x is equal to 5. And in fact, you can check that if you plug that in there, 5 minus 3 is 2, and 2 over 4 is 1. Which is the same thing. And then looking at number 8, I need to get my exponent by itself first. So that's going to be e 2x.
Genesis Dowdy, please come to the main office. Genesis Dowdy, please come to the main office.
Take the natural log of both sides. So I get 2x is equal to the natural log of 9. We'll just divide by 2. What's x equal to? I can say natural log of 9 over 2. Or if I am approximating that, 1.099. going to do two more, a little bit more complicated. I can't make number 9 have the same base, so I'm going to take the natural log of both of those. So natural log of 5, and the reason why I'm doing that is I can bring this out front, is equal to 2x plus 3 natural log of 4. Remember to take the natural log, you can read that exponent out front. And now I'm going to distribute that. So this is going to be x natural log of 5 minus 2 natural log of 5 is equal to 2x natural log of 4 plus 3 natural log of 4. Now I need to get my things with x's on one side and my things without x's on the other, just like we would in any equation. So I'm going to minus this, and I'm going to minus this from this side. Put my x's together. Now they're not the same, the natural logs, but I still can get them on the same side, and that's going to help me solve this problem. 3 natural log of 4 minus 2. Now, since I have both my x's on the same side, I can factor out an x. And natural log of 5 minus 2 natural log of 4 is equal to 3 natural log of 4 minus 2 natural log of 5. And then I can divide so I can get my x by itself. And then I'm done. That's what x equals. X equals 3 natural log of 4 minus 2 natural log of 5 divided by natural log of 5 minus 2 natural log of 4. You could put that in your calculator. I get negative 6.34. All right, then we're going to look at this last one. Hopefully that looks familiar to you. Sometimes with these we have to use what's called substitution, which you could do. You could change this into x squared minus 4x plus 3 so you can see it better. And then you can factor that to solve. So you factor this would be x minus 3, x minus 1. Now you need to go in and put in what we were using for x, and what we're actually using for x was e to the x. So this would be e to the x minus 3 and e to the x minus 1. You don't have to do the replacement. I just let x equal e to the x, so that way I could do the easily factor that without thinking too much about the e. Now I have two equations that I need to solve. Set those equal to 0. So e to the x minus 3 equals 0. E to the x minus 1 equals 0, just like you would do with the quadratic. So e to the x equals 3, and e to the x equals 1. Now I need to solve those. I take the natural log of both sides, that will be x equals to the natural log of 3, which again, if you're not allowed to use a calculator, you leave it that way. X is equal to the natural log of 1. Natural log of 1 was one of our rules. We know that that's 0. Natural log of 3, we have to put in our calculator. That's approximately 1.096. So that is solving exponentials. Now let's look at logs. They have some of the same rules. So we're going to look at simple and hard, or complex. So simple. When they're simple, everything is in a log, the same things. So combine logarithms on each side of the equation using your properties. So if I look at this example, I see that those are added, so I can make this log of, I can multiply those together, x squared minus 3x equals log of 4. This thing's on the other side. They're all the same piece based Then I can use my one-to-one property, that was on the front, that's the one-to-one property, that would say my arguments are equal. We go back real quick and look at that. What am I talking about? One-to-one property right here. Same base, and that means that my arguments have to be equal. So I can use that, say x squared minus 3x has to equal 4. And then I solve, so I'm going to move 4 over, I can see it's quadratic, I'm going to have to factor, hopefully nothing more. I'm looking at factors of -4 that add to give me -3, so x minus 4, x plus 1 equals 0, so I have two solutions, 4 and -1. Now, here's the issue. You got to think about these solutions. A couple different ways to do it. Some people just say plug them in and see if it works, which is a valid method to use, but you have to know what x can be. I know this is just apparent, so x is domain, remember, was 0 to infinity. For this one doesn't get affected, it's 4 no matter what. This one, I know that it's going to be 3 to infinity, because remember this has to be greater than 0, and you saw that. So looking at those, are there any that won't work? Well, yeah, the -1 is not going to work. 4 fits in both of those. It's greater than 3 and it's greater than 0. So that is the only solution. So that's the extra step here. You have to eliminate things that can't possibly be answers. We didn't have to do that with the exponentials because if you remember, the domain for the exponential was all real numbers. All right, what about if we have a more complex problem like this next one that we have? You would combine, isolate the logarithmic expression. Then you're going to, well, let's do that first. Do that before we get to the 2. So right here, they're being subtracted. So I know that's division. So that's log 5 of x plus 2 over x equals 2. Then I need to rewrite in exponential form. That's what we had to practice doing all that on the day we did logs. So this is 5 squared is equal to x plus 2 divided by x. Now I can solve it. Again, I have to make sure when I do solve it that I'm careful and that I look at any values that it can't be. So what values? It's going to go from -2 to infinity and then from 0 to infinity. So that's what I'm looking for. So now I have 25x, so multiply by x on both sides, is equal to x plus 2. Subtract x, 24x is equal to 2. And you can divide by 24, so x is equal to 1. So now I have to look, I only got one answer, but I do have to make sure that it'll work. So I look at my rules, and 1/12, yes, it fits in both of those. It's greater than -2, and it's greater than 0, so it's going to be fine. All right, let's do some examples. The first one, we're going to have to use quadratic formula, so we'll come back and we'll do that one last. Let's look at some other ones. First one I see is kind of simple is this number 30. Looking at that. If I look at that problem, I know what x is just by looking at it because this is a base 10. So what's x going to be? I'm taking the log of, and this goes back to our properties that were on the front, our inverse property. I'm taking the log of a base raised to a power. So my answer is just that power, and the power here was log 100. All right, let's take a look at number 2. That's kind of an easy one to do. X minus 2 to the power 2 is 25. So I'd have to factor that So factor that out, or multiply that out, that's x squared minus 2x plus 1 equals 25. Move this 25 over. You get x squared minus 2x minus 24 is equal to 0. So factors of negative 24 that add to give me negative 2, x minus 6 is plus 4. So two possible solutions, 6 and negative 4. This one's a little different. Well, same, pretty much. It's the parent, so I know that that's my domain. There's no horizontal shifts there. But, so I know it can't be negative. And actually, I can check that just by looking. If I put a negative 4 in here, my base is negative, and the rule with logs is they can't have a negative base anyway. So that one is eliminated. All right, let's work 4 and 5, and then we'll come back and do number 1, and that's what we've got with quadratic polynomial. This is going to be 3 to the third is equal to x minus 1. In fact, actually, I'm happy with doing this one. It's not too bad. 9 is equal to x minus 1. Solve that. And we get x is equal to 10. Again, we still have to think about, will it fit? This one would be 1 to infinity. Remember, we made that x minus 1 is greater than 0. We did that 2 classes ago, so we know that we have to be greater than 1. And this is greater than 1, so it does work. All right, number 5 has a couple to think about, so I'm going to do all of those domains first. Domain of this one would be 3/2 to infinity. Solving that. Domain of this one is 0 to infinity. And then domain of this one is 2 to infinity. All right, now let's take a look at it. Oh, not too bad. First, we're going to notice that the right side has an addition, which means we can write it as multiplication. So we're going to condense it. X squared minus 2x. Then, because they're the same logs, we can use the one-to-one property. So we know that 2x minus 3 is equal to x squared minus 2x. Then we can put everything together. So we're going to move everything over. We end up with x squared minus 4x plus 3 equals 0. So now I'm factoring it. And it's going to factor into x minus 3, x minus 1. I'm looking at those solutions. There's 3 and 1. I'm going to go up and look at my domains. 3 works for everybody. Greater than 3/2, greater than 0, greater than 2. 1 doesn't work. 1 doesn't work here, and it doesn't work here. So that's going to be an issue. It's not going to work. So we 3. You can also test it in here if you wanted to. You plug a 1 in and see that would be the log of a negative 1. We can't do that. And this would be the log of a negative 1. We can't do that either. X has to be positive as well. All right. Let's look at number 6, and then we'll go to that quadratic formula one. Number 6 is also a special one. So I can't do any condensing. I could look at it as e to the 7th, e to the 7th is equal to 3 minus x squared. We're going to take the e of both of those. Do that. Or I can even look at this as being a log e of this. And how do you write that? E to the 7th equals that. So either way it works. That's why that property works. Then I need to solve for x minus 3. E to the 7th minus 3 is equal to negative x squared. Divided by that negative 1. Negative e to the 7th plus 3 is equal to x squared. So if I put this in my calculator, I mean, I have to take the square root of both sides of it. I'm just going to put this in my calculator first. I'm already suspicious that something's not quite right. This is actually negative 1,093. Can I take the square root of a negative number? Not in the real number system, that's what we're doing. So this one doesn't have any solution, so it's not possible. Now, how often is that going to happen? Not too often. I mean, I'm testing you on it, I'm not going to make it happen. All right, now let's look at the one I've been avoiding. Number one, mainly avoiding it because I know I'm going to use the quadratic one. All right, so I can put these guys together. So that's going to be log 2 of x squared minus 3x equals 7. So writing this is going to be 2 to the 7th is equal to x squared minus 3x. Yeah, 2 to the 7th is 128. And then minus 120. That's got a lot of time to find factors that works, and they don't. So we're going to have to use the quadratic formula. So negative b, so 3 plus or minus the square root of b squared, so negative b squared is 9, minus 4 times 1 times negative, so we call 128, all over 2 times 2. It's going to be 3 plus or minus the square root of 521, all over 2. So then I tested it. Well, when I plugged in the positive one, because remember, 0 to infinity here, there's going to be 3 to infinity, so it's going to fit in focus. When I tested the positive one, it worked. So you can plug that in, 3 plus square root of 521 divided by 2, it ended up being in the right area, but when I did the subtraction one, 3 minus, it doesn't. So the only one it is 3 plus square root of 521. Whatever that was approximately, didn't write it down, so you could write it also. All right, that is it. Go ahead and try the classwork and the homework.